Back then, a draft in the wrong corridor, heat bleeding through a wall panel, or condensation in a bunker was more than a structural annoyance. It was a signal, a leak. And the people running those underground command sites treated thermal losses exactly like they treated intercepted radio traffic, as vulnerabilities to be tracked, decoded, and eliminated. Engineers walked tunnels with gloved hands, searching for faint temperature shifts. Watchmen monitored frost patterns on exterior facades. Maintenance teams marked hotspots on steel bulkheads the same way counterintelligence marked suspicious communications. If there was heat escaping where it shouldn't, there was risk creeping in. And the truth is that same mindset can save homeowners and off-grid builders money, materials, and frustration today. Because a house that leaks heat is a house paying double for the privilege of discomfort. If you've ever wondered why your heater runs constantly, or why the room you're standing in feels colder than the rest, you're dealing with the same basic challenge engineers faced beneath 2 meters of reinforced concrete. Today, we walk through how to detect and eliminate those leaks with the precision of a field operative, and the practicality of someone who wants a warmer home without spending a fortune. The first step is understanding that every thermal leak creates a signature. Nothing in the physical world hides perfectly, not even heat. Old military bases proved this every winter when snow melted faster above poorly insulated bunkers. That same principle applies to modern homes, barns, workshops, or safe rooms. Heat naturally moves from warm zones to cold ones, and anywhere the building envelope is weak, the transfer becomes obvious if you know what to look for. You don't need expensive equipment to start. Your own senses are often enough. Just stand near exterior walls on cold mornings and move slowly around door frames or baseboards. Feel for moving air and pay attention to the temperature gradient from floor to ceiling. These small checks, reveal the pattern of a structure losing energy. A practical beginner's step is performing what builders call a cold weather sweep. Close exterior doors, shut off fans, and let the building sit quietly for a minute. Then walk the perimeter from the inside. If you feel even a faint movement of air near outlets, windows, or joints, you've identified a leak. This simple approach, actually mirrors how early engineers use flame sticks or smoke pencils to track drafts inside bunkers long before thermal cameras existed. The method still works because air infiltration hasn't changed, only our tools have. The second step is using low-cost detection tools that act like field surveillance gear. While professionals rely on infrared cameras, most people don't realize how accessible entry-level thermal scanners have become. Even inexpensive phone-based devices can highlight cold bridges, missing insulation, and gaps behind trim. The key is to scan during temperature extremes, early morning in winter or late evening in summer. You're looking for abrupt transitions rather than gradual ones. A sharply defined cold stripe down a wall often signals a stud bay with no insulation. A halo around a window frame suggests a break in the air barrier. A bright warm patch near a ceiling in winter reveals rising heat slipping out through the roof structure. For those without thermal devices, another practical trick borrowed from civil defence facility tests is the incense trail. Light a single stick and hold it slowly near edges, corners and junctions. If the smoke pulls, swirls or moves in a consistent direction, you've found air movement. This technique is especially effective around attic hatches, crawlspace doors and rim joists, areas where homeowners lose heat constantly without ever realizing it. The third step is sealing major leaks with the same layered philosophy that protected bunkers. Military engineers always applied multiple barriers rather than relying on one material to do everything. That same logic works perfectly for home heat retention. So start with air sealing. Caulk gaps around trim. Add gasket seals behind outlet covers on exterior walls. And use high-quality weather stripping on doors. Then move to insulation. If you discover a cold stud bay, you can drill small holes at the top and bottom and inject dense pack cellulose, a method that requires minimal demolition and honestly mirrors how crews retrofitted old bases without tearing down walls. Attics are often the largest source of heat escape. Cold War facilities added deep layers of mineral wool to slow conductive losses, and homeowners can, apply the same principle today with blown-in insulation. Even adding a modest 10 to 15 centimetres can dramatically reduce thermal escape, especially when paired with proper air sealing around chimneys, vents and light fixtures. The fourth step is addressing hidden thermal pathways most people overlook. Heat doesn't just slip through walls, it travels along materials. Metal conduit, steel beams, uninsulated concrete, and even tile can create thermal bridges. One way to interrupt these pathways is with thin, rigid foam panels or thermal break tapes. For example, if a basement wall feels cold along the vertical line where rebar or a footing lies behind the surface, affixing a foam panel over that section can break the conductive path. In workshops or garages, add a strip of insulation between metal frames and the exterior sheathing. These strategies are simple but incredibly effective, and they were used extensively in NATO storage depots, where even a few degrees mattered. The final step is confirming your fixes the same way an intelligence team verifies a repaired breach. Now, once you've sealed and insulated, you'll want to repeat your earlier scans. Just run your hand along the old leak points and, test with smoke again to be sure everything's holding steady. If you have access to a thermal device, do another full sweep. The goal is to ensure your corrective action changed the building's thermal signature. When you see fewer cold spots, or when the air movement has disappeared, you've officially tightened your thermal envelope and reclaimed control of your energy bills. This is the moment modern homeowners share with past engineers. The satisfaction of knowing your structure is finally defending itself properly. If you found this guide useful and you want more deep dive breakdowns on forgotten engineering, bunker technology and real-world home hardening tactics, make sure you subscribe to Thermal Vault and share this video with anyone trying to build smarter, stronger and more efficient.